Good morning, good afternoon, and good evening. Welcome to our sneak peek at an exciting new feature of InterSystems Iris that we're calling Embedded Python. My name is Bob Kuszewski. I'm a product manager here at InterSystems, and today we're going to provide you with a glimpse at our upcoming Embedded Python feature. I'll start with a brief introduction as to what is Embedded Python and why I think you're going to love it. Then I'll go through an example and a very short case study about where you might want to use it. Embedded Python is not a finished product. We're working on it right now. So I'll close with a short discussion of where we are as far as development is concerned, and I'll invite you to help us make it great. So let's start with, what is Embedded Python? Embedded Python is a fusion of Python with ObjectScript and Iris. That is, both the Python virtual machine and the ObjectScript virtual machines are running side by side inside the Iris process. You can invoke methods on Python objects from ObjectScript, and you can invoke methods on ObjectScript objects from Python. It all just works. Having both runtimes together allows for what I call toll-free bridging between the two worlds. You can pass objects from one language to another without having to serialize them in between. So why did we choose Python? We chose Python really for three main reasons. There's the ecosystem, first and foremost. There are thousands and thousands of high-quality packages pre-built and available today, especially in areas like data science, IoT, bioinformatics, the cloud. Python's also been around for a long time. It's been around since 1991, and it's still in use today. It's growing in popularity, in part because it's a very easy language to learn. Cheap and free classes are available all over the world, online, universities, books, professional development courses. So it's something that people can learn quite easily. And the third reason is that Python fits really nicely with Iris. It's designed to be embedded. Its runtime is very similar to the Iris runtime. Type compatibility is very straightforward. While ObjectScript and Python have very different histories, they have a lot in common. They're both what we call object-oriented, dynamic, interpreted languages with full polymorphic dispatch. Both use reference counting for object lifetimes, and both are written in C. This deep simpatico of the languages allows for even deep capabilities in each environment to just work. So let's take a look at what SQL in Python will mean. We plan to make embedded Python available to SQL developers in the code-bearing structures of SQL, specifically the four places that are shown here on the slide. From the SQL developer's point of view, we're adding Python alongside the existing SQL and ObjectScript options for the language tag. So let's take a look at what a Python example might be. So here is an example stored procedure, very simple mortgage payment calculator. So the syntax is normal SQL create procedure. The language, Python clause has been added, and the body is in those curly braces, just like the language Python, language ObjectScript you would need to do. And then you see that what's indented inside those curly braces is Python. You will need to indent everything, but that's just pretty straightforward for any Python developer anyway. You have full Python features in there. Import just works, as you can see. So does print. Parameters to the procedure are available as variables, as you might expect, and you return via, well, the Python return command. So all the things that you would expect would work, just work. So let's talk about use cases. Why would you use language Python? So in a lot of ways, it's the same reasons that you would use ObjectScript, right? You've got some complex units of work. Say you had a very complex algorithm, far more complex than my mortgage calculator, right? or the data that you're selecting is stored in many places and you have complex business logic to kind of sort it out, big reports and those sorts of things. Maybe even data that's stored in globals but not in a SQL table. Or your data isn't even in Iris yet, like you're loading a CSV file from disk or you're connecting to a cloud service. Those are all things that you can do with embedded Python for SQL. And one of the primary reasons that you would use Python remains its deep, rich ecosystem that simplifies all of the above use cases. Like my previous example, the NumPy library that I imported, it just worked, and I didn't have to write my mortgage calculator function from base materials. So let's go through a quick case study. I'll show you what some signal processing of time series data to measure market volatility. So what is time series data? So time series, I think you all know what this is. You intuitively know what it is. But in case you haven't heard the term, time series is any data that's captured with a timestamp. Like an ECG is a time series. Precipitation data from the weather is a time series. Employment data from the government is a time series. And of course, we're all accustomed to stock tickers being time series. And it's used in a wide variety of applications with a ton of research going into optimization and prediction types of tools. Everything from how to most efficiently deliver your Amazon order to predicting which patients in the ER are most likely to have a heart attack. These are all analytics on time series. So for our case study, we're measuring market volatility, figuring out how do we calculate that. In this case, we want to measure the volatility of Apple's stock. Here's a chart of Apple's stock price over the last few years. On the left, we see the chart of Apple's stock price, and on the right, we see its frequency distribution, which tells us that Apple's stock is not stable. In fact, it's generating quite nice returns for investors. Now, while that's great for investors, that Apple stock is going up, many statistical techniques require what's called a stationary signal. Visually, that means it looks like the signal is flat overall. So one of the most common techniques to create a stationary signal from a real-world signal is to use log returns, which is also known as log differencing. Log returns is a simple function, it's right up there. Log returns has a number of excellent statistical properties. For the purposes of our conversation today, the most important one is that it gives you a frequency distribution that's centered around 0. And now that we have the stationary signal, we can use both classical and machine learning algorithms on it. Most of both classical and machine learning statistical algorithms for financial data, you really want a stable data set that's brought in first, a stationary data set that's brought in first. So here we see that the signal processed through some standard statistical techniques, and in particular, the rolling computation of the standard deviation is known by the special name volatility. So that, if you've ever wondered, that's where market volatility is measured, and that's where that comes from. So let's see what this looks like in Iris with embedded Python. Here we see a pseudocode implementation of what market volatility calculator would look like in Iris with embedded Python. Note that this is just a couple of lines of code to compute the volatility thanks to the existing Python ecosystem. In a few more lines of code, we could compute any number of other signal processing algorithms. The SciPy signal library has pre-built filtering, detrending, anomaly detection. There are other libraries for interpolation, decomposition, frequency domain analysis, nearest neighbor analysis, which lets you do some really cool time warping stuff. You could also pull out your old differential equations book and use other nonlinear and dynamics. And of course, there's machine learning. You may have heard by now that Iris has integrated machine learning features. So some other examples. So it's not just signal processing that you can do with embedded Python. You could use JSON path to extract data from JSON documents. You could build your own custom data loader. You could use bioinformatics libraries like BioPython to slice or mutate a genetic sequence. NetworkX provides a truly impressive library for working with graph data. Say you wanted to compute betweenness or optimize a route. And of course, whenever you're working with images, there are a host of other opportunities for feature extraction. So for all of these cases, Embedded Python will help you get the job done faster. So where will you be able to use Python in Iris? So Integrated Python is being used today in support of our new Integrated ML feature that I'm sure you've heard of. We're also working to add it across the rest of the Iris ecosystem. So if you want to hear more about how ObjectScript and Python are coming together, you might want to see my other Visual Summit presentation on Embedded Python from the ObjectScript developer's point of view. Embedded Python is a feature that is still in active development, and we anticipate rolling it out in phases. I've listed here a few things that we anticipate supporting Embedded Python with, but I'm sure that there are ideas that you have that have not come to my mind. So your key takeaways from today is we have access with Embedded Python now to many thousands of embedded libraries that are ready to go, they're high quality, ready to be built upon. Simplicity, right? The things Python and ObjectScript can work together. So if you have some stored procedures in ObjectScript today, but you want to rewrite them to use some Python, you'll be able to do that. And I know you all want to know this. When is this going to be released? It's going to be released in phases. The first phase we are anticipating being Iris 2021.1 for Iris in SQL. All right, what are your next steps? So if you're intrigued by the potential for Embedded Python, please consider sending email to the pythoninterest@intersystems.com email address. We're putting together a technical advisory group and are looking for customers who can help us shape this offering. For those of you who are interested in machine learning, we have a great many integrated ML sessions at this year's Virtual Summit that I highly recommend. And as I said, I did another presentation on Embedded Python from the ObjectScript developer's point of view that might potentially be interesting to you. So if you'd like to connect, my name is Bob Kuszewski. My email address is right up there on the screen. If you can spell my last name, that's how you can get in touch with me. And once all that's left is for me to say thank you. And I hope you're having a great Virtual Summit.